pair and it is exerted by driving gear to driven gear. So if you refer the diagram, so this is the pinion, this is the driving gear, and this is the driven gear. The power is transmitted by a force exerted by the tooth. So assume that this is the tooth. I will highlight here. This is the tooth on the pinion. It will exert a pressure, it will exert in this direction, and it will exert this particular teeth of the gear, and the power is transmitted. It is exerting a force Pn. It is the resultant force acting on the gear tooth. And according to fundamental law of gearing, this Pn is always acting along the line, pressure line, where it makes an angle alpha, pressure angle alpha. So this is the resultant force. This is the basic structure diagram. Then there are some assumptions. The above force analysis, whatever we are discussing, it is based on certain assumptions. So we have to take an account on what assumptions it is based on. So as the point of contact moves, the magnitude of resultant force Pn changes. The effect is neglected in the above analysis. See, I will highlight. Where is the point of contact? See here. I am highlighting. See. This is the point of contact. You refer in the figure. I am highlighting. This is the point of contact. As the gear is moving, the pinion is rotating in this direction, the gear is rotating in this direction. The point of contact will also move, because the pair will transmit, the pair will come at the center, and again it will move. So the point of contact will continue to move on changing. And the point of contact changes, the magnitude of this Pn will also change. But this effect is totally neglected in the force analysis. As the point of contact moves, the pinion is transferring the force on the gear. The pinion tooth is transferring the force on the gear. The point of contact started at one point. The pair will engage for a certain time, and again there is no point of contact will be there, and they will get completely separated. Again the next it will come in contact. So this continues. But the point of contact is continuously moving, and as this point of contact is moving with the pinion and gear, the resultant force magnitude is also changed. But this effect is neglected in the analysis. This effect is not considered, neglected in the analysis. This is your first assumption. Then it is assumed that only one pair of teeth takes entire load. See here, whatever analysis we are making, we are taking in account only one pair. Is it possible in the gear? No. So if you refer the gear, the pinion contact starts here. Again, here may be the another pair, and here may be the pair where point of contact is about to end. So point of contact begin, point of contact is in progress, and point of contact about to end. So it is starting from this and it is ending at this point. So approximately on an average, there are two pairs or more than two pairs are in contact. So at a time, there are two pairs are simultaneously in contact to share the load. This aspect is neglected. It is assumed that only one pair of teeth takes the entire load. This is the assumption made in force analysis. Third one, the analysis is valid under static conditions. Static means not exactly stationary. Static means stationary, it is one concept, but other concept is the when it is running at very lesser velocity. But in practice, if the gear is rotating at 1000, 1500 RPM, then there will be acting the dynamic forces due to the power transmission. And the effect of these dynamic forces is also not considered, either neglected. The effect of dynamic forces is neglected in the analysis. So these are the three assumptions made. First is, I review that at the point of contact moves, the magnitude of resultant force Pn changes, but this defect is neglected. When the gear is transmitting the load, at all times there are two pairs which are in contact simultaneously to transfer the load, to share the load. This aspect is completely neglected, and it is assumed that only one pair is there which is taking the complete or entire load. And third one is the analysis is valid under static conditions. When the gears are running at low velocity, it is used. And when dynamic, it is rotating at higher velocity, dynamic condition. So this aspect is not considered, neglected. These are the assumptions. Now let us see, we have seen about the Pn. Pn is the force acting along the pressure line. So the resultant force Pn can be resolved into two components. First component is tangential component and second component is radial component. The Pn is resolved into two components as tangential and radial. Tangential component is denoted by Pr and and radial component is denoted by Pr. So see here in the diagram, this is your Pn. This is your Pn. So Pn is the component if you see, and it is resolved into two PR. So Pn is resolved into Pt tangential force and Pr radial force. This is for driven gear. And for driving gear, again it is resolved into two. The directions are opposite. Again, let us see. The tangential component Pt is useful load because it determines the magnitude of the torque. So the tangential component is useful component. Due to this tangential component only, the gear is rotating in this direction. Due to this tangential component only, the gear is rotating, whatever shown, the gear is rotating in this direction. So it is also called as useful load, useful component because it determines the torque. We will be discussing the torque in this MT is equal to PT into this d by 2. This is just force into perpendicular distance. So this is the force acting PT and the perpendicular distance is diameter by 2. So PT into d by 2, it will give you the torque and you can ultimately calculate the power. So this is the useful component. Due to this component, the gear is rotating and the magnitude of torque and consequently power can be calculated. So this is about the tangential component. Now the radial component. The radial component is acting toward the center. Means for gear, it is acting toward the center of the gear. For pinion, it is acting toward the center of the pinion. It is always acting toward the center. And it is also called as separating force. It will try to separate the two gears. It will try to separate the two gears. It is separating force. Now, one more point is here, the direction. So I will clear you the directions. The direction of PT tangential component. The direction of PT tangential component is always in the direction of rotation and opposite for the pinion. See, once again I will repeat, the direction of PT is always PT, see here, in the direction of rotation, because as PT is in this direction, the gear is rotating. Therefore, the PT, direction of PT is always in the direction of rotation and the PR is always directed toward the center. This is the, we are using for gear, and for other case, for pinion, it is exactly opposite to gear. So these are the important considerations while giving the directions in the force analysis. So the directions, once again I will repeat, PT, it is in the direction of rotation for gear and opposite for pinion, and PR is always directed toward the center because these directions are required in case of helical gears also. So accordingly the directions are shown. Now let us move to formulas. The torque transmitted by the gear is given by MT. In this machine design second, this terminology, instead of T, it is showing MT. So we are using the sign convention as MT instead of T. So MT is equal to 16 to 10 raised to 6 kilowatt divided by 2 pi n. You have to note it down. So it is just based on P is equal to 2 pi nt divided by 60. In that case, T is in Newton meter. Here T is in Newton millimeter. And in that case, power is in watt. Here power is in kilowatt. Therefore, the formula sum 10 raised to 6 is shown. So very first formula, MT. If power is given and RPM is given, you can easily calculate the MT, torque transmitted by gears. If power is given and RPM is given, you can easily calculate the torque MT. So here MT is equal to torque transmitted by gears, Newton millimeter. KW is the power transmitted by gears. Here notation is always used the KW. If you will get the answer KW is equal to 3.5. So it is assumed that power is 3.5 kilowatt. So there is no notation for P as power. It is KW. And N is the speed of rotation. So this is the torque transmitted by gears. You can calculate torque if the RPM and power is given. And if power we have to calculate, then if we can calculate the torque and RPM is given, simultaneously we can calculate the power also. So this is the very first formula for any gear design calculations. First formula will be this one, calculation of torque. So note this down formula. Then the tangential component PT. Now Pn is the component. It is in the pressure direction. We don't want this. We want to calculate MT, and MT can be calculated based on PT only. The force which is causing the motion, due to which the motion is caused. Therefore, PT is important. Therefore, whatever in this diagram shown Pn, the Pn no direct significant as far as the calculations are concerned. This force Pn no direct significance as far as calculations are concerned. PT is the very important. We have to calculate how it is acting. So tangential component PT acts on the pitch circle radius. So if I want to calculate the torque, then I can say PT into whatever the diameter divided by 2. So radius. PT into radius, it will give you the torque, force into perpendicular distance. So PT and radius is nothing but d by 2. It will give you the MT. MT is the torque in Newton millimeter. So now you can transfer, you can rewrite that as PT is equal to taking this 2 on another side, twice MT divided by D. I am writing here D. If you are calculating this for pinion, you can calculate DP. DP means this is the D and suffix P is attached, then this is for pinion. Okay, so PT is equal to twice MT divided by D. Now, relation between PR and PT. If I will say from this relation directly it is written, so I will write for you here. Tan of alpha is equal to, by referring to the figure, tan of alpha is equal to opposite side divided by adjacent side. Opposite side I can write PR, as this side is PR, means this is also PR. So PR divided by adjacent side, you can write here clear cut PT. So how I can write PT then? This is, and how I can write PR. If I want to write PR, then I will simply say PR is equal to what it becomes? PT into tan of alpha. PT into tan of alpha. Very simple. So from the figure, tan of alpha is equal to PR by PT. Therefore, PR is equal to PT tan of alpha. So from figure, it is directly written here. PR is equal to PT tan alpha. See, we have to calculate in any of the example PT. If force analysis example will be asked, PR. Very less cases Pn will be asked. The resultant force Pn, you can again calculate. Pn is equal to Pt by cos alpha. So if you go for Pn, relation between Pn by Pt, you can write here cos of alpha is equal to Pt divided by hypotenuse Pn. Therefore, Pn is equal to Pt by cos alpha. Very simple. So you can calculate Pn. So as per as our terminology and calculations are concerned, this is very first important formula. I will, if in the numerical it is asked to calculate the PR and PT, the radial and tangential component acting on the gear, you have to calculate, and then you have to go for calculation of PR and PT and represent it on a free body diagram. Then you will go for this condition. Very first RPM is given. You will put here substitute RPM. Power is given. You will substitute. You will get the answer for MT is equal to whatever your answer in Newton millimeter. So this is very first step. Then after calculation of this MT, you will go for calculation of second step PT. PT is equal to twice MT divided by dP. So twice MT we have calculated, diameter is given. I will calculate PT in Newton, and then directly I will calculate PR, and I will calculate PR is equal to PT into tan of alpha. Alpha is given, PT we have calculated. So you will get this answer. PR is equal to something Newton. So this is the force analysis and the directions. I have already explained you about the directions also. So in this case, if you want to go for one additional thing as the directions, then I can go for, see just here, try to concentrate. So this is your one, assume that this is the pinion, and again I will assume this as the gear. So if I will assume that pinion and gear pair, so if I will assume that these are the, for example, take this as pinion, smaller part I will take this as gear. This is one point where you have to show the force. This is one point where you have to show the force. Now assume that pinion is rotating in clockwise direction. Assume that pinion is rotating in clockwise direction. Definitely the gear will rotate in anti-clockwise direction. The gear will rotate in anti-clockwise direction. So in this case, I will show my PT. In this case, I will show my PT as PT for this gear in the driving direction. This should my PT. PT is always in the direction of rotation of driven. PT is always in the direction of rotation driven. And this is your PR. Okay, so this is the force analysis. And opposite to this, the PT is always in the opposite direction. You can show here for first case, whatever opinion is there, and this is your PR. So this is the direction for force analysis. For more understanding, I have cleared you that this is the direction. So when it is asked to go for the force analysis to calculate, then you can easily calculate by using the formula, very first EMT formula. You can calculate the EMT. Just now we have discussed EMT is equal to 16 to 10 raised to 6 kilowatt divided by 2 pi n. Calculate EMT. Next step, calculate PT. Next step, calculate PR. And next step, show the force analysis. So this will be your the force analysis. Again, you go for some drawing like this here, and you can mark this point as O1, the circle, the center. Again, you show here the center as O2. So this is your free body diagram, which is indicating the force analysis. Okay. So we have discussed. Let us summarize. Let us summarize. We have discussed about very first what is the minimum number of teeth required for a gear. Then the formulas, what is the practical condition and theoretical formula for this minimum number of teeth. Then followed by the face width, what is the face width desirable from 8 to 12 times of module, and generally it is taken as 10 times of module. And then we have gone for details, this force analysis of the spur gears, then what are the assumptions made, then this is the detailed force analysis we have gone for, and these are the formulas, and this one example I have given you how to go for the force analysis directions. So